Okay, a very good evening to my fellow friends and my teacher. Okay, my group is going to explain about trigonometry in architecture. Okay, first of all, I'm going to list out all the group members. First, it's myself, Kablisko Vidraju. And second is Suvinalisan Ramamurthy. Then third one is Saileshwar Rishapillai. And then the last one is Satishwar. Okay, now we're going to see about what is trigonometry. Okay, trigonometry is a branch of mathematics that studies relationship between side length and angle of triangle. Okay, what is trigonometry? Now we can separate the word trigonometry into two. The first one is trigono, and then the other side is metry. Trigono in meant triangle in Greek, and metry is meant by measure in Greek. So together it's called trigonometry. Okay, trigonometry is all about triangles. Trigonometry helps us to find the angle and distance in a triangle. Okay, there are 6 functions of an angle used in trigonometry. They are sine, cosine, tangent, cotangent, secant, and cosecant. Okay, the main 3 angles are used is sine, cosine, and tangent. The other 3, cotangent, secant, and cosecant, are the root from sine, cosine, and tangent. Okay, as you can see, this is the basic trigonometry we study in the class. Okay, there's hypotenuse, opposite, and adjacent. To find this angle of sine, we need to use the formula of opposite and hypotenuse. For cos, you must use adjacent and hypotenuse, and then tangent, we use opposite and adjacent. As a synchronyme, they are SOHCAHTOA. So is defined as sine, opposite, hypotenuse. C is cos, adjacent, hypotenuse. T is tangent, opposite, and adjacent. Okay, in triangle, there are 6 basic elements. The basic elements are 3 sides and 3 angles. The most used triangle in trigonometry is right angle triangle because it's the most easiest triangle in trigonometry because it consists of 90 degree in basics. Okay, now we are going to see is what is architecture. Okay, architecture is the art and technique of design and building. Architecture is when art and engineering come together in the design of building. Okay, for in simple word, architecture is designing the structure of building. It uses both art and engineering equally so that it can build one amazing building and attractive building. Okay, the architecture is the profession of architect. Architect are the people who work as an architecture. Okay, there are many types of architecture around the world. So now you're going to see a few examples of types of architectures. Okay, the first one is residential architecture. Okay, residential architecture is basic. Residential architecture, they build houses only. For example, in Malaysia, there's one group called Masing Group. It's one of the famous group that build houses in around Malaysia. Okay, the second one is commercial architecture. Commercial architecture is basically they will design shops, office tower, hotel, museum, and government centers. Basically, they will design all the non-residential architecture around the world. Okay, the third one is interior design. Interior design is as known as we know, interior is meant by the inside of an object. Interior designer will be design the interior of an house or of an office or of an restaurant, so the people who work inside or live inside will be amazed. Okay, the fourth one is landscape architecture. Landscape architecture is a design and development of an outdoor spaces. For example, they will build private and public garden, building walkways, golf course, resort and park. Most of the Malaysia in Johor, the most famous park is and theme park is Legoland, and then the most famous park is the bouquet in the roundabout because it contains park inside and roundabout. So it's one of the famous thing in Johor. And then the fifth one is urban design. Urban design is architect who specialize in urban design, are involved in city planning, and focus on the design of an area as a whole building. They will design a whole city based on their design lah. So they will design one whole city so that the city will look spectacular around the world. Okay, the last one is industrial architecture. Industrial architecture is basically designing warehouse, factories, storage building, logistic facilities, and power plant. Okay, now you're going to see the example building around the world use trigonometry for construction. Okay, the first one is Taj Mahal at India, one of the famous love symbol in the world. Okay, as you can see in the image in the slide, they use triangle, right angle triangle to determine the height of top of the Taj Mahal and until the bottom of the Taj Mahal. And then you can see they use angle also to determine the height. Okay, as you can see in the left side, they use the blueprint of Taj Mahal and consists of triangles. So it tells that triangles and trigonometry will help us to build construction very easily. And then in most of engineers, they will use triangles and trigonometry formulas in their blueprint so that they can find the actual length between two spaces. Okay, the second one is Petronas Twin Tower in Malaysia, in our own nation. Okay, as you can see, there's a bridge between two towers called a sky bridge. As you can see in the picture, they used right angle triangle to determine the length between two towers so that they can build one structure that's strong using a triangle. Okay, thank you. And then I would like to call my another friend to explain about the application trigonometry in architecture.
Guys, I'm Saleshwar Shapile and I like V. Ravindran. I'm from DKM 1A. So today I'll be presenting about applications of trigonometry in architecture. Ancient architects had to be a mathematician. This is because trigonometry is simply a mathematics. So buildings and structures are made up of various types of materials such as glass, steel and gravels. These object has different curves and angle which are very complicated. So by using trigonometry functions, the sine, tangent and cosine rules, they can be determine the perfect height, angle and force that should be applied on the object. So let's look into real life applications. So number one, we're going to look into the Grand Canyon skywalk, which is located in US. So this skywalk doesn't has any support in the base, and also on top there's no any cables to support the skywalk. It's literally hanging 4,000 feet above the sea level. So if you look down, it's a empty land 4,000 feet below. Is it safe? Yes, it is very safe, so don't worry. So architecture uses the right angle triangle to determine the distance from the base to the edge of the triangle of the bridge. So forces push and pull from different angles are represented as a vector. Y vector? Vector is used as the hypotenuse of right angle triangle to determine the pressure that should be exerted on the bridge. So this will not cause any damage, and also by using trigonometry it shows a precise reading that should be carried out. So next we're going to look into the Great Pyramid of Giza. So this is the Egyptian's most mysterious building. So the Rhine preparers demonstrate their use of primitive trigonometry function. It is used to calculate the slope of the pyramid. So the measurement used to calculate is secant of pyramid. So you can look above there. That's the actual measurement of the Great Pyramid Giza. So secant of pyramid is also known as cotangent. Cotangent is the adjacent over opposite of an triangle. So that is how.
Greeting to my teachers and my fellow friends. Today I'm going to talk about trigonometry in architecture and mathematical solution with drawings. Trigonometry play a crucial role in architectural designs. Architects apply this maths form to plan their blueprints or initial sketch of designs. They also calculate the probability of which a construction team could run into as they bring the design vision into life in 3 dimensions. Here are some questions that I prepared for you guys. So question number one, we should find the height of AB. To find height of the AB, we must use tangent. So tangent equals to opposite over adjacent. So given the adjacent equals to 50. So tangent 60 times by adjacent 50, we will get the height of the building, which is 86.6. Here's another question. In this question, we can divide two triangles in different angles to find the height of x. In the first triangle, which is the angle is 40, we can find the total height of the build tower. So tangent 40 equals to opposite over adjacent. So tangent 40 times by the adjacent, which is 87, we will get the total height, which is 73 feet. So in the second triangle, which is the angle is 25, by using the same formula as tangent opposite over adjacent, we'll find the opposite, which is the height by tangent 25 times by the adjacent is 87 equals to 45.57. To find x, we must minus the total height with the small triangle's height. So 73 minus 45.57 will get 27.43. Third question, we must find the height of the building. Given the angle of the triangle, which is 55, and the adjacent was 57. To find height, we must use the formula tangent, which is opposite over adjacent. So tangent 55 equals to opposite over adjacent, which is 57. So tangent 55 times by 57, we will get the height of the building, which is 81.40. That's all. After this, satisfied will give with the conclusion. Thank you.
Greetings to my teacher and my fellow friends. Today, I'm going to tell you about the conclusion of importance of trigonometry in architecture. First of all, we can realize that trigonometry plays a critical role in architecture because trigonometry is very useful in determining the unknown side of a specific triangle. So, they can help in calculating in architecture. In this field of work, we are able to apply the knowledge we learned in analysis of right triangles in determining the height of a tree, pole, and even a building. Moreover, trigonometry doesn't end in passing the trigonometry subject, and also we will use it always in our engineering career because trigonometry can be widely used in our real life applications and it's very useful for most architects. In determining the height of the building, we are able to master the reading of the vertical angle using theodolite. What is a theodolite? Theodolite is an instrument that can measure angles between designated visible points in horizontal and vertical planes. Since the digital and transit theodolite have been used by many architects and engineers, they can be used for other purposes as well. Now, as you can see, we can surely tell that without trigonometry, our life would be much more difficult because with the help of the trigonometry, You can easily find the height of a tree or a pole by without even climbing on them. So it's very true that trigonometry was a good invention by Archimedes, and thanks to his inventions, so many architects and engineers doesn't need to go through the trouble to calculate unknown side of a specific triangle. And here, we can surely conclude that trigonometry is really very important in architecture. Thank you.